Okay, splitting this video up gives you a little break. The rest of this we're going to talk about joint or compound probability. And this is the probability that two events, or both events, A and B, are taking place. So when calculating compound or joint events, it's crucial to know whether they're independent or dependent. So again, we kind of talked about, do they affect each other's outcomes or not? So they're independent if they don't, they can handle it on their own. They're dependent if one affects the other. So for example, just to give you some ideas, let's state whether the following are independent or dependent. So Anne draws a colored toothpick from a jar. Without replacing it, she draws a second toothpick. Now, because she keeps it out, and then she draws another toothpick, right? Because she kept it out, there's less toothpicks in there. So these would be dependent events. And again, you could try and figure these out before you watch the rest of the video if you'd like to. The next one says John rolls a 6 on his number cube and then flips a coin. The roll will not affect the coin flip, so that means those are independent events. Susie draws a card from a deck of cards and replaces it. She then draws a second card. Because she puts it back, those would be independent events. Cal reaches into his pocket to find a coin to pay for his ice cream. He chooses a nickel first, then reaches in to grab a second coin because he needs more money. So if he doesn't put it back, then those are dependent, right? There's less money in his pocket. The next one, Donald spins the wheel to know how many spaces to move while playing life. Because he lands on a 10, he gets to spin again. That spinner, right, just because he landed on a 10 the first time, it doesn't affect the next spin. So those would be independent. And then lastly, being dealt a hand of 5 hearts. Maybe it doesn't think like it would be if you're just dealing those 1, 2, 3, 4, 5, but every time you deal one, then it changes the number of cards in the deck. So we would consider those dependent events. So if this is what we're looking at, then we want to jump down and talk about how we calculate those. If they're independent events, then we want to calculate the probability of A and B. So remember, this is and. Both events occurring. Then we just take the probability of A and we multiply it by the probability of B. When you multiply the probabilities, right, of two of these independent events, the probability of both of them occurring is usually less, right? For two things to happen. If they're if they're dependent, we calculate the probability of A and we times it by the probability of B, given A already happened. So we'll talk about what that looks like. So here we go. It says you randomly choose 2 marbles, replacing the first marble before drawing again. From a bag containing 10 black, 8 red, 4 white, 6 blue. Notice it says replacing it, so you put it back before you draw another one. Find the probability of each of the following. So it looks like we have 10 black, 8 red, 4 white, 6 blue. Again, I'm going to use the notation so we get the hang of that. It says find the probability that you get white, and then red. So we look at these as 2 separate events, right? The probability of the first times the probability of the next. Because we're putting it back and replacing, they're independent. So the probability we get a white would be 4 out of the total marbles. So let's add these up. We have 10 plus 8, 18, plus 4, 22, plus 6. Looks like we're going to have 28 marbles. So as we're calculating this, I'm going to write this over here. That would be 4 out of 28. Now if you put it back, now what's the probability we get a red the second time? That would be 8 out of 28. But because we want both things to happen, then we go ahead and we multiply those together. You can leave it as a fraction if you'd like to, or just go ahead and write it as a decimal once you make that multiplication. B, a red marble is not selected, then a blue marble is selected. So again, I'm going to put down here not red first, then blue. So we first look at not red. Well, 8 of them are red, and if there's 28 total, that means 20 of them are not red out of the 28. And then we multiply it by the probability we then get a blue. There's 6 blue in there, so it's 6 out of the 28. And we go ahead and multiply that together, and we end up with 0.153. A green marble is selected, then a green marble is selected. Well, if I'm looking for the probability of green, then green, I look up and it looks like there's no green in my bag, so 0% or 0. Lastly, this says a blue or black marble, so it can be either on the first one, so probability it's blue or black. Oh, that says black. Then a white marble selected, so, and then red. Red. Wearing a red shirt, maybe that's why. All right, blue or black. So if we look up here, it looks like there's 10 black, 6 blue, so that's 16 out of the 28, times a white one next, so probability it's white would be 4 out of 28. And then again, you're going to go ahead and multiply those. I'm not afraid that we can't do the multiplication well, because the calculator will do that part. We just want to be able to set these up correctly. Okay, let's look at these last few examples. Using a full deck of cards, what is the probability of being dealt 2 jacks? Okay, so now we're being dealt, so I want you to think about it. This is dependent, right? Because you're going to deal 1 jack and then assume you got one before you deal the other. So this is the probability you get a jack, then a jack. Okay, so think about the first event first. The probability you get a jack is going to be 4 jacks in there, 1 of each suit out of the 52 cards. Now, if you've already been dealt a jack, think about how many jacks are left. If you already have 1 in your hand, there's only 3 more in the deck. And if you already have a card in your hand, there's 51 cards left in the deck. So that's what it means when it gives you this formula here at the bottom of the last page, where it says you find the probability A happens, and then the probability of B, given that A already happened. So we assume you were dealt a jack when we calculate that. And then if you go ahead and calculate it, this probability is very small. So we're looking at only 0.5%. Probability of drawing a heart. So again, just kind of combining these all together. Notice only one thing is happening, and there's 13 hearts in the deck, so 13 out of 52. A fourth of them are hearts, so there's a 25% chance. Probability of drawing an ace. Putting it back, so these ones won't affect each other, right? Shuffling and then drawing that same ace. So that's very specific. So in here, first of all, just the probability we draw an ace to start with. There's 4 aces, right? 1 of each suit in the deck. And then if we put it back and shuffle it, that's a very specific card. So there's still 52 cards in there, and we're looking for one specific card, right? That one specific ace. So we would go ahead and multiply that and get our decimal. That looks like it would be a very small decimal. Okay, then the last one, another example, just to give you a couple different contexts. This says a bag contains 20 $1 bills and 5 $100 bills. You randomly draw a bill from the bag. Set it aside. Oh, that's important, right? We're keeping the money out. And then randomly draw another bill from the bag. So event A, the first bill is $100. And event B, the second bill is $100. So it says, are event A and B dependent or independent events, and explain why. Now that verbiage that I highlighted, they set it aside, right? That means there is a different number of dollar bills the second time you draw. So these are definitely dependent events, okay? Because, we'll explain, you kept the first bill. Okay, so because you kept the first bill drawn, the probability of the outcomes of the second draw are affected, or is affected. Okay, so if these are dependent events, it says find the probability both will occur. So the probability that you get $100, right, and another $100 on your second draw. So if we're looking at this, we would say the probability I get $100 on the first one, well, there's 5 of them in there. And if you look at how many bills are in there, it says there were 20 $1 bills and 5 $100 bills. So total, it looks like there's 25 bills in there. Now, again, if you are calculating the probability you get another one, we're assuming you already drew a $100 bill, so now there's only 4 left, and we decrease the number of bills in the bag by 1, so we go over 24. And then we calculate. Okay, the big takeaway on this one again is if they're independent events, great. Find the probabilities they all occur, multiply them together if they're all occurring. If it's a dependent event, then you have to make sure we account for what happened in the first event and how it affects that second